Okay, so today we are going to take a look at the BAe 146 in Microsoft Flight Simulator, or more specifically we're going to look at programming the flight management computer in the BAe 146. So let's go and jump inside the cockpit, and we don't need the tablet today, so we'll get rid of that out of the way. Okay, so we're cold and dark, so we're going to take the setup of the cockpit as far as getting the flight management computer up and running, and then I'm going to take you through programming a route by hand into the flight management computer. So first thing we do, we go overhead and turn the batteries to on. We turn the lights above further up on the panel to high int. We turn the no smoking sign to auto. We turn the cabin emergency lights to armed. Over on the other side, we turn the yaw dampers to on. We turn the autopilot master switch to on. Avionics A and B to on. We turn the anti-skid light to on. Far left, here we go. Anti-skid is here, and we turn on the yellow and green lift spoilers. Then further down on the overhead panel, we go to the electrical section and we want the bus tie AC and DC, so they're here. We're setting them to auto. Next we want the standby inverters and standby generators to armed, which we have just done. APU gen to on. APU gen's down here, you have to click it twice to switch it on. Fuel pumps to inner left, and then master switch on the APU to start, and the needle will start moving around. So the reason for doing all of this is to start getting the aircraft ready for flight, but also get the APU on the auxiliary power unit, which will give us electrical power throughout the aircraft. So once the needle has spun all the way around to 100, you will see the power will cross-feed and the systems on the aircraft will suddenly power up. So electricity available sign will light up. Okay, so there we go. APU power is now available. We arm the emergency lights as soon as we have electrical power. We go to the central console and we switch on the yaw dampers. Then we go back to the cockpit, and again this is a point of contention with some people. This is in the checklist, but some people say you don't need to do this unless you're using the masks. We're going to do it. Okay, so we've done the oxygen, so we go back overhead and we send the center tank transfer to auto. So that's over here. So if you've got fuel in the center tanks, this will feed from the center tanks, or feed the center tanks out to the wing tanks until the center fuel tank is depleted. We're nearly there. Ice detector on, so we undo the cover down here, we turn ice detection on, we close the cover. We back in the co-pilot section of the cockpit, we click on this flip chart. It's a bit of a cheat really to move these markers to the takeoff positions. We turn the flight directors to on. And we turn on Nav 1. We turn the comm radios on. So we come down and we turn them on. Right, and now finally we get to look at the flight management computer, which is what we were going to talk about for this video. So we're going to program a route by hand and show you how to do that, and kind of some of the ways you can manipulate a route even when you're in flight. So the first thing you need to do is go to position initialization. It's worth pointing out the flight management computer in the 146 is the working title flight management computer from the CJ4. Okay, so this is not the accurate flight management computer for this aircraft, but it's the one that comes with it that JustFlight have bolted into it. And you know, they made a very good trade-off and said, look, we're going to spend our time getting the rest of the aircraft working right, when it would have taken months to program a brand new flight management computer. So they've chosen to retrofit one from another aircraft that's fairly close, and they've switched a lot of buttons off that are, you know, that are just not there anymore. Okay, so normally you would have to go and fill in your position, but that's already done for us, so we don't have to worry about that. So we can go straight to flight plan. So what it wants is the origin, that's where we are at the moment, and the destination. So what it's actually asking for is the Icao code of the airport. And if you want to have a look at some Icao codes, this is a free piece of software called Nav Map that loads the database from Flight Simulator, so you get the scenery on a map. So if we were to zoom in, for example, you can see some of the airports. So there's Heathrow, which is EGLL. Down here we've got Biggin Hill, which is EGKB. And then further down this way is Farnborough, EGLF. And Gatwick, EGKK. So these are the Icao codes for the airports, and that's what flight management computers typically want. So we will go and have a look. Our aeroplane is on the ground at London City. So our origin or departure for our flight is EGLC, Echo Golf Lima Charlie. So we type in Echo Golf Lima Charlie, and you can see it's typing in this bar between the square brackets. This is known as the scratch pad. So we can type anything we like in here, and then we can press a soft key, so one of these buttons alongside the display next to the field where it's expecting input, to transfer what we have typed into that field. So we click there, so you can see it's left the scratch pad, that's now empty, and we've got an origin for our flight. So now we need a destination. So for our example flight plan here, we're going to fly from London City. If we zoom back out with the mouse wheel, drag across, we're going to leave the UK, head east into Europe, and we are going to land at Amsterdam Schiphol. So the code for Schiphol is Echo Hotel Alpha Mike. So we type in Echo Hotel Alpha Mike into the scratch pad, and then click the key next to the empty field, and there you go. So it's programmed it in, and you've got a verification there of the distance in case you have transposed some letters or something and it's a valid airport, but it's, you know, 1,000 miles away or whatever. You will have noticed there were square boxes in those fields versus hyphens for the others. Square boxes in an FMC tend to mean that's a mandatory field and you can't leave it. Also, you will notice at the top right it says 1 of 2. There are some page buttons down here, next and previous. So we'll go next. So what it's asking for here is if we've got any more legs that we want to program. We don't have to do them at this point. So if we go previous, we can see what we've just done. So we've put in the beginning and the end of our flight plan. If we actually go and click on the legs page, you'll see a view that shows the beginning and the end with nothing in between at the moment. So what we can do is go and look at our flight plan now. We've got some, if we just expand this out, we've got some actual instrument flight procedures. So a standard instrument departure and a star, or a standard approach route. So the SID, or the standard instrument departure, is a sequence of waypoints that are dictated by air traffic control. So in Little Nav Map you can see them all by saying show me the departure procedures on an airport, for example, and you can see them all there. So if we were to flick through these, you can see where they go with the line on the map that we haven't actually chosen. There's the one we chose, is the DVR5U departure, but there's lots of others. So those are kind of standard routes that the ATC would give you for your flight plan, or that, you know, or that your flight planning would turn up to say or our company uses this route into and out of this airport, or ATC might give it you as well. So you will notice the whole idea, if I just clear that off the map and clear that screen out of the way, the whole idea of a standard instrument a standard approach route or a standard instrument departure is it's a sequence of waypoints, so you don't have to program them all yourself. You just say, I want this sequence, please. So let's see what we do to set the DVR5U standard instrument departure. So if we come back to the flight, we've got the flight plan here. We want to go to the DEP-R button. That means departure arrival. If we say DEP-R, it's defaulting to show us the departure from EGLC. So we can say, what runway are we taking off on? We're taking off on runway number 9. So we can select runway number 9, and you'll see this side changed. This is a list of the standard instrument departures. And when we selected a runway, it filtered it down to only the ones that apply to runway number 9. So we're looking for DVR5U, and you can see it's not on the list. The next and previous page buttons apply. You can see there are 2 pages. And there we go, DVR5U. So we select that. We have now chosen a runway and a departure, and we can execute that change. So that is now in our flight plan. If we now go and look at the legs page again, you can see we've got actually 2 pages of legs. So you've got D020N, LON27, BEMID. If we go and look closely at this, D020N, LON27, BEMID, and so on. Okay, so it's programmed all of that into the flight management computer. And we can go to the next page. It goes DET, DVR, and then suddenly it goes over to EHAM, which is the destination. So you can see it gets as far as the Dover VOR, DVR, and then jumps straight to EHAM. So it's missed out all of this because we haven't programmed it yet. So we need to go to the DEP-R button again and set up the approach route into Amsterdam. So let's go to the DEP-R button. Now you can see at the moment it's still showing EGLC or London City departures. We need to go to the DEP-R index page. So we click on that button. We can now choose to either do the departure or the arrival. So we're going to arrival, and it knows it's EHAM because we keyed it earlier, remember, on the flight plan. So EHAM, and we want to come in on, we can see here, runway 06, using the ILS for runway 6 and the Denu 3A star. So ILS runway 6 is there at the top of the list, and the Denu 3A star is right at the top of the list. There are actually 3 pages of different stars, but we can just choose that one. Okay, it's got some transition points there as well. That gives you variations of the route that go through different specific waypoints. And again, if you have got a flight plan that you're programming in, it might actually name the transition as well. We're not going to bother in this case. We're just going to execute saying use Denu 3A and ILS 06. So we're not going to use one of these variations that goes through a very specific waypoint. Okay, so if we go and look in our legs page now, we'll see it's got even further. There's 4 pages of it now. So if we go and look through, we can see this is the route in. It's even programmed a missed approach. So when we go and look in here, we can see, actually it doesn't show you on little nav map, but it's actually got it in here, what to do in the case of a missed approach. So we can also go to previous. Notice in between the end of the standard instrument departure from London and the beginning of the approach into Holland, or into what's it called again, Schiphol Airport, there's this line in between with squares where it says it's a discontinuity. This is standard on many flight management computers, that when you've put a standard instrument departure in and an approach into another airfield, it doesn't try to guess how to join them. It puts a line in between ready for you to put some extra bits of waypoints in, and it calls it a discontinuity. So in other words, it won't guess. So what we can do then is go in between these two, and maybe we'll put in a waypoint along the way. So there's one here called Madux. So if we right click on that in little nav map just to see what it would look like, we can put that waypoint in along the way. So we'll type it in here into the scratch pad, MADUX, and we insert Madux in, and there you go, the discontinuity has vanished. and the flight plan is now complete, and we have to execute it. If we don't execute it, the change only exists here on the screen. It doesn't exist as far as the aeroplane is concerned. You will have seen there was a cancel mod there, so if you make a change and you think, oh, I've done that wrong, you can just cancel out before executing and it will ignore what you've just done. And you can do many changes before you execute. You don't have to execute each individual change. So the next thing to look at is, okay, maybe we wanted another one actually after Maddox, but there's no discontinuity there to fill in, so how do we do that? So let's go and have a look. We'll pick another waypoint, so we'll zoom in, find one with a nice name, Noyon. So we'll add that one in as well. So we actually want to go after Maddox, we want to go to Noyon. So all we have to do over here, oops, let me just move this over a little bit. And I'm just playing around with the view. So Noyon, N-O-Y-O-N. So what we do is we press the button next to the waypoint we want to move down to make room for this one. So we want this to happen before Denat. So Denat was the beginning of the standard approach route. So if we say put Noyon in there please, and there you go, Noyon is now in between Denat and Maddox. Okay, and we can execute that, and that's now part of our flight plan. Now, something to bear in mind is you cannot insert extra waypoints into the middle of the SID or the star, into the middle of the departure or the approach route. You can only do it in between them. And by the same token, if you delete a part of a SID or a star, the whole thing will vanish. If you want to delete a specific waypoint, you can just get rid of that whole waypoint, of that individual waypoint. So if we say the delete button here, it will say delete, and then we can click on the waypoint we want to get rid of, and that's now got rid of Noyon. So that's closed the gap back up for us. You'll notice along the way you can also see some flight levels that have been programmed in. You can program these in yourself on your own waypoints. Obviously in a SID or a star, well, it's probably not obvious if you didn't know this, you sometimes get altitude restrictions. So this plays into VNAV, but it also gives you the reference if you're not using VNAV to say, you can see during this descent into Schiphol, we have to be below a certain altitude at this waypoint. We have to be between two altitudes at this waypoint. And by the same token, when we come out of London, we have to be at a specific altitude when we get to a particular turning point there. So yeah, you can program those in by using these keys down the side as well. So you can put in like a speed at the flight level if you need to. Other than that, that's about it for the basics. So that's how you can program a route. Obviously then when you're flying, to get the airplane to follow that route, what you have to do is switch this little yellow switch here to RNAV, and once you've done that, you can switch on LNAV and VNAV over on the master control panel for the autopilot. Yeah, if you're in RNAV mode over here, which really means FMS or GPS mode, it's just that this aeroplane predates a lot of that, so it's labelled RNAV on the panel. So if it's in RNAV mode, what it means is the autopilot can follow the flight management computer. If you switch, and something to bear in mind with that is if you are in RNAV mode, nothing you do to the nav radios is going to make any difference to the aeroplane. Yeah, and this is actually going to show the status of the flight management computer, or the direction to the next waypoint. It's not going to show anything about what you've got tuned in on the nav radios. To get the nav radios to work again, you have to switch this little yellow switch back to nav, and then suddenly the nav radios will reflect on the CDI, or course deviation indicator, on the primary flight display. Okay, so hopefully that makes a bit of sense. So we've looked there at the computer. Now, if you do want to completely throw away your route and do something completely different, all you have to do is go into flight plan and change the origin. So type in a different code. If you change the origin, it wipes out everything you've done. So you're starting from scratch. Something else worth looking at that's hidden in the aircraft, if you go to the index page, so IDX, you can do a hold. So you'll have noticed, say we were flying along and we got to Maddox and we actually wanted to put ourselves into a hold because we had been asked to do that. So we could say, this is what a hold might typically look like. And it means the airplane's going to fly along here and then fly this racetrack route for a few minutes until we're given instruction to carry on. So all you have to do is go to index in the flight management computer, click on hold, then select where you want the hold to start. So say we were going to say at Maddox we want to do our hold, and we say execute that. Oh sorry, no, we have to then click on the square boxes. So we put Maddox into the scratch pad. So it's basically saying when we get to Maddox we want to hold. So then we get to put in the coordinates or the description of the hold. So by default it's going to come in on the direction we were going, and it's going to do 1 minute leg times, hold 200 knots, and do a distance of 2.3 nautical miles, and we can execute that, and that will actually put it into our flight plan. So when we look at legs now, if we go next page, we see Maddox, and you say hold at, and then carry on at the end. If we cancelled that hold, it would carry on flying the route. So if we want to remove that hold, it's just like deleting a waypoint. Yeah, so you just delete and get rid of the hold, and it's gone. It's now doing a hold at DVR and execute. But yeah, so you get the idea. You can insert holds, you can remove the holds. Something else that's interesting actually, if you go into hold, yeah, you can see the same one is still listed there. Just it's just the configuration from previously. We can do a new hold, and we can put one in and say actually we want to do it at somewhere completely different. DVR, and this could be at any point in a SID or a star as well that you can put a hold in. Yeah, so it starts to stack the stuff up, which is fine, and obviously you can delete out everything you need to along the way. So holds are quite clever, because otherwise you'd have to be obviously flying that route and working the angles out and the timings yourself, which it's worth pointing out before airplanes had all this stuff, you usually have a chronometer. That's what it's there for. It's for timing the legs of holds. Yeah, so that's why you typically have a chronometer somewhere around an aircraft cockpit. It's the days before these electronic systems, before an autopilot could fly a hold. If you were told to do it, you would have to go and time it yourself. And what I mean by timing it is the timing of these legs. Yeah, this is doing like a 1 minute leg at 200 knots. That's what it would look like on the map. Okay, but you don't. The likelihood is, if you're not flying with ATC, you're not going to see holds, to be honest. You might want to just go and play with them for fun though, just to see how they work. Something else that's worth looking at, if you go to the index page, you can go to the progress page, which gives you your estimated time to the next waypoint, which is really good. The legs page does something similar, but it just gives you distances. The progress page actually gives you timings and distances. Okay, so there you go. So we've looked at putting the initial flight plan details in, we've looked at putting legs in, manipulating the legs, putting standard instrument departures in, and approach routes by choosing them up here. And again, you can re-choose them. Once you've chosen one, you can go and re-choose it. You don't have to have it set in stone. If you take off without setting a standard instrument departure, you can't then set it once you're in the air. It has to be done on the ground. But in the real world, you wouldn't be setting an approach route until you're in the air, because ATC, and depending on weather changes, and ATC at the other end would confirm it. So you may not program a standard approach route until you're in the air. and that's fine. You know, you can take off and you can fly with. That's why you saw an execute for doing the SID, and we didn't have to set a star or an approach route. You could fly without the approach route programmed and program it on the way. Okay, so I think that's probably flogged that horse to death. We've got nothing left to say about the FMC really. I'm not going to fly the route. This was just to show you the ins and outs of programming it. There are, you'll notice, because this has been retrofitted, there's a load missing from it, like the performance pages and things like that. All this is going to do is basic, you know, holding you on the route. So there you go. That's the flight management computer that is retrofitted into the BAe 146 in the Microsoft Flight Simulator. And I'll speak to you again soon.